Okay. Maka, why is your camera off again? You don't want to show your face to others? So that's much better. Yeah, I can see your face. Did you just wake up?
No, I'm not. I woke 2 hours ago, maybe.
Did you go to school today?
No, it's no, I didn't.
Okay, good. Daphne, how is your holiday going in Turkey? Is everything okay? Okay, maybe she's not here. Maka, if you are ready, let's start. Ibrahim, are you here?
Can you hear me?
Yes.
Okay.
Yeah, I was talking actually.
You're talking to whom?
I was talking to you. Like my whole day was going very well, and today is actually like my dad's birthday.
Really? Today is the
Yes,
1st of March. Wow. So how did you celebrate, or you didn't celebrate yet?
we kind of did. I guess we did. I mean, did the whole birthday cake and stuff, but nothing much.
Hmm. Yeah, that much is enough. Just remembering and sitting together, maybe eating some delicious food and cutting a cake and maybe giving some presents. And that's it. Okay. All right. Maka, just I want to ask you one question. Okay. This question, for example, okay. This question, did we solve these questions? Not yet, right? We stopped here the last time. Is it the last question with it in the last class?
No, it's not us. We have our own questions 12.
Really?
Yes.
How come? We did these questions together, right? Yeah, we did this question because I already wrote here,
Yes,
and the
we
last
did this
question was
question too.
Sophie German prime, right?
Yes.
Okay, good. Ibrahim, do you remember this question?
Yes.
Okay, guys, very good. Then we are on the same page. Okay, we are talking about the same thing. All right, and we will continue from here. And 16 to 25, they are a little bit different. Not difficult question. Let's say you need to think. Okay, and also there are no only options offered here, so that's why you need to solve it and write your answer. And also in Sasmo, your answer must be 100% correct. Otherwise, you don't get any point. Maka, let's start. This read the question. And let's try to solve at least 8 questions today. Maka, can you read the question?
Okay. Find the largest 7-digit number which contains all digits from 1 through 7 such that difference of any two of its consecutive digits is a prime number.
Okay. So we are given 7 digits from 1 to 7. Okay. And the question here is, the challenge here is, let's say, we need to actually form the biggest 7-digit number in such a way that if you just pick any two numbers next to each other, their difference must be a prime number.
Yeah. Sorry for waiting. My Wi-Fi was off.
Okay. All right. Guys, can you try just maybe 1.5 minutes? That's not a difficult question. And since it is saying the biggest number, so that means that we need to start with 7, right?
Yes, we have to start with 7.
Water, please. Maka, did you get anything?
No, I didn't. I'm thinking about this question.
Well, that's so easy question. Musa, how about you?
I found, but I didn't think it's correct. 7654321.
Okay, tell me again. 7.
Did you actually find?
654.
Oh, how can it be 6?
321.
How can it be 6, Musa? 7 and 6, the difference is 1. 1 is not a prime number.
Why? Because 1 and 1. No?
No, 1 is not a prime number. The smallest prime number is 2.
2?
Yeah, what is a prime? Prime
Yeah.
number, actually, it has exactly 2 different divisors, right? 2, 3, 5, 7, 11. These are prime numbers. But of course, here it's 1 to 7. The difference cannot be greater than 7. Even it cannot be 7, right? Because here the maximum, the biggest difference is 5. Yes, Daphne, what did you say? Did you find something?
No, teacher, I couldn't find something. Actually, I feel like, can I ask something, teacher? Can, like, for example, the numbers with something after, like, um, after 0, can they also be prime?
Can it be negative?
For example, like 1.3, can that be prime?
No. When you just say prime number, we mean actually integers. Or even at school level, which only mean positive integers like 2, 3, 5, natural numbers. And Musa, you are saying that negative, we mean the difference, okay? Difference means if it is 3, 5, 5, 3, the difference is the same. The difference is 2.
But I'm just asking,
Okay.
like 1.3
Thank you.
be,
Sona, how about you? This is very easy question. Why can't solve this? Sona Mirzaeva. Okay, guys, actually to form the biggest number, right? Actually, the first digit must be the biggest number. And let me just write here 7. Okay. So the second digit also, it must be the biggest, the possible biggest number. Let me just write our numbers 1, 2, 3, 4, 5, 6, 7. Now I have already used 7. The second digit cannot be equal to 6. Otherwise, the difference is 1. 1 is not a prime number. So the next biggest number will be only 5. As you see here, 7 minus 5, it is 2. 2 is a prime number. So also it is gone. And next number, can it be 6? No, 5, 6, it is 1. 1 is not a prime number. 5, 4, the difference is 1. Also, it cannot be 4. And next biggest number is 3. As you see here, 7 minus 5, it is 2. 5 minus 3, it is 2, prime number. And also, I have used 3 here, right? And again, the next one, among these numbers, remaining numbers, which one is the biggest one? 6. So can I write 6 here? Yes, if I write 6 here, what is the difference between 3 and 6? It is 3. 3 is a prime number. So also we have used, what is it? 6 here. Now, if I use 4 here, right? If I use 4 here, remaining 2 numbers are 1 and 2. The difference is 1, so I cannot use 4 here. So how about 2? If I write here 2 here, 6 minus 2, 4. 4 is not a prime number. So the only choice here is I should write 1. As you see here, 6 minus 1, it is 5. 5 is a prime number. So also 1 is used here. Now I cannot write here 2, right? Because 1 and 2 difference is 1. So the only choice here is, it is 4. And after that, we have here 2. As you see here, if you just look any 2 different digits adjacent to each other, the difference is a prime number. 7, 5, prime, 5, 3 prime, 3, 6 prime, 6, 1 prime, 1, 4 prime, 4, 2 prime. And that is the biggest possible number. That satisfies the given condition in the question. So what is that number? 7, 5, 3, 6, 1, 4, 2. Okay, Maka?
Okay.
Good. Maka, read the question.
In the diagram below, ABCD is a square. CDE equal to 72 degree and CED equal to 54 degree. Find the angle of EED.
Okay.
EAD.
EAD. Very easy question. Okay, I will give you 2 minutes. Let's see who can solve this question correctly. Very easy question. Ibrahim, are you here?
Is CED is a triangle?
What?
Is CAD is triangle?
CAD?
Yes. No, E.
CAD is a quadrilateral.
No, like CED.
CED?
Yes.
Yeah, of course it's a triangle.
Okay, thank you.
Musa, it doesn't look like a triangle?
I don't know. Sometimes they put something fishes and it's how to say. I discovered it was wrong.
Sona, why is it taking so long? Musa? Maka? It's very easy question.
I don't know.
I think I'm close to the answer.
Okay, 1 more minute, okay? 1 more minute, let's see. Any answer?
Maybe it's 72.
72.
Yes.
72? Okay, from here, we know that it's a square. We know that that means that all sides are equal, right? All the sides are equal.
Is
So
the
now this
answer 90?
90,
Yeah.
I don't think so. It cannot be 90. We will see. Okay, it's not 90. Suppose that this angle is, let's say it is alpha. Okay. So as Musa said, CED, it's a triangle. That means that alpha plus 54 plus 72, it should be equal to 180 degrees. Now from here, what is alpha? Alpha equals 180 minus 72 plus 56, it is 126. 126. That's equal to 54 degrees. That means that this alpha equals 54. That means the opposite alpha, opposite 54. These two sides are equal, right? Because CD is equal to ED. Why? Because the angles are equal. And also at the same time, AD is equal to EF, which means that if this angle is X, and also this angle should be X. And since we know that one interior angle of a square is 90 degrees, so this should be 90 minus 72, that's equal to 18. So now from here, X plus 18, that's equal to 180. Or 2x is equal to 180 minus 18, that's equal to 162. So what is x? X equals 81 degrees.
Yeah, I was so close.
Really?
Yeah, like I didn't have much time. Like I found like ED is equal to AD and it is XX, but
I actually
time for
didn't
solving.
read it like enough.
What did you say, Daphne?
I would have found it if I like read it enough. And firstly, that secondly, it has kept me like out for some reason. It just throws me out like every single minute. It's like very windy here, so that's why I'm guessing.
Okay. All right. Guys, let's move to the next question. That's it. Musa, can you read the question?
The number below is made up of a odd digit as a digit of the one number from 1 to 2000 to 2016. Find the number of sevens in this number. Find the number of sevens in this number.
Maka, did you understand the question?
It's easy.
Yes.
Easy? Let's see. It says that we are just writing numbers until 2016. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The question is to write this number. Suppose it's a very huge number, right? How many times did we use 7? Or simply, we need to find the number of digits, sevens in this number. Musa, in how many minutes you can find?
It looks like the like a question like there's a cube and there's like a cubes like how many times 17, how many times 77, how many times 777, like this.
Okay. Is 3 minutes enough? Can you find the number of sevens in this number in 3 minutes?
Maybe.
Oh, okay, let's see. Time starts now. Is question 20, Musa? Usually questions 20 to 25, they are not that easy questions. I mean, I agree with you, the methods you're going to use, but you need to count fast. Musa, did you get anything?
No.
Maka, how about you?
I think it's. I found the methods, but I'm so close. I think it's more than 1,200 sounds.
More than 1,000?
Yes.
It's a lot. Daphne, how about you?
Teacher, wait a second. I'm solving it.
Sona?
I'm very confused. I don't know what way to use actually.
Okay, simply Sona, what you have to use here is, guys, let's continue, okay?
Teacher, I found the 1,211 and 11.
Oh, it's a lot.
Yes.
Okay. So one systematic way of counting these numbers, okay, you can just write like this. For
Teacher,
example,
I
here we have,
found it.
huh?
It's like 338. Yes, 38.
No, it's more than that, Daphne. It's more than
I
500,
think
less
it's
than 1,000.
300.
Okay. Look, if I just write the numbers
Wait
in
a
a
second.
column, like we
It's
have
like
one digit
19 over
numbers,
10.
right?
Yeah,
And-
it's 308.
Okay. So the answer is, we will see. Okay. So first, let's just count the number of sevens in ones digits. Okay. So first, I will just count a number of sevens in ones digits. So ones digit means, what are these numbers? Like 7, right? And I have, after 7, what we have here, like 17, and after that 27, right? And continue, here we have 97, right? And 107, and continue until 2007, right? I'm just counting the number of sevens used in the ones digits, the last digits, okay? How many sevens do we have here? As you see here, starting from 007, right? And until 200, right? So how many sevens do we have here? We have, it is starting from 00 until 200. So here we have 201, because we are starting from 0. If you start from 0 until 9, for example, 0, 1, 2, 3, 4, 5, 6, 7, 9, how many numbers do we have? It is 10. I'm not starting with 1, I'm starting with 00. That's why here we have 201 sevens. Okay. Now the second one is, we will count the sevens in tens digits. Tens digits means it is, what is it?
182.
wait, is tens digits. What is tens digits, right? For example, the first one is tens digit is, it starts from 70, right? This tens digit means this from the right, actually, the second digit is 7. So that is, here we have 70, right? And 71, and continue. Here we have 79, right? And after that, here we have, what is next, actually? The next one is 170, 171, continue 179, and continue like this, right? And until seventh digit, it will be, what is it, 19, I think, because after 2000 we don't have any digit in the tens digit, right? So that is, what is it, 1970, 1971, and 1979. As I see here, all sevens are in tens digits, right? 70, 70, 70, 70, 70, 70. So each one, right? How many sevens do we have here? Starting from here again, 0 until 9. In each group, we have 10. But from 7 to 1,700, 1,970, how many groups do we have here? So here we have 10 numbers, and here we have 10 numbers, dot, 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 and here we have 10 numbers. How many tens do we have here? Right? Start from 70, right, until, what is it? It is 0, 0, 70, 0, 17, 1970. So that's equal to 1967 minus 7. It is equal to, was it 190? $20, right? Is it 20? 20. Because 70, starting from 70, 170, 270, 370, until 1970, right? Starting from 0, 0, right? And the 0, 1, and continue until 19. If you start counting from 0, 0 until 19, here we have 20 groups of tens. In each group, we have 10 sevens multiplied by 10. So here we have 200 sevens are used in tens digits, or for tens digits. And the next one is for 100 digits, 100 digits. So what are these 100 digits? It is only like 700, right? It is 701 until 799, and 1,700, 1,701, and 1,799. That's it, I think, in hundreds digits. We don't have any. So here, how many do we have here? From starting from 700 until 99, 100, 100. So that's equal to 2 times 100. That's equal to 200. That's it, right? Because in thousands, right, we don't have any 7. We don't have to count. So we just counted sevens used for tens units digits, and after that tens digits, and after that 100 digits. For 1,000 digits, we didn't use any 7. So altogether, how many? 201 plus 200 plus 200. That's equal to dot, dot, dot. The answer is 601. Musa 281. No, Musa, the answer is 601. Maka, did you understand? Okay, and that's
Yes,
why
I
we are
understand.
always, we need to count, if we need to find a kind of systematic way to count this. Otherwise, it will be confusing. So the best way is but ones digits, tens digits, and hundreds digits, and in this way you can count much, much faster. Okay, guys, let's
But why,
continue. Yes.
like, first of all, I count how many sevens are from 1 to 100. Then I show like 2,200, like 100 multiplied by 20, and and I found like it was 14 numbers, and I 14 multiplied by 20 and add plus 1, because in numbers from 1 to 16 is 1, 7. I didn't know why my method is wrong.
Musa, when you calculate it
because
like
we
this,
missed
it will
like
be confusing, okay? Because you can miss some numbers. Also, you can count, but at the time it will be really confusing. But if you just count sevens, which are used for units digits, and after that tens digits and 100 digits, that is the best way to count the number of digits used to form this number.
teacher actually did the same way with him. But I just like forgot the fact that there's like hundreds digits, so that's why I think
Hmm.
that's where I
Okay.
went wrong.
Now, at this guy, you have some idea, you have experience. Next time, you should be a little bit carefully and try to count this, okay? And for example, to practice this, how about the number of twos, for example? How many twos are used? Or how many ones are used? They may ask in this year's question. But here at the time, not until 2016, how about until 2021? Okay, let's move to the next question. Musa, read the question. Maka, read the question. Maka, you read the question. Since I can see your
Find the
face.
sum of the digits of the product.
Definitely, this is also a very easy question. Okay, it's really easy question. Just simple arithmetic. Okay, I will give you 3 minutes. Let's see who can get the answer. The question is clear, right? Here we are given a number which has 2016 digits. Actually, here we have 2016 ones, and we are multiplying this number by 2016. So we will get a huge number, right? The question is, what is the sum of the digits of the product? Okay, of course, in usual way, we cannot add this up, right? We cannot add this. So that means that we need to have some kind of pattern. Okay, can you find this pattern? And after that, find the sum. Okay, and let's see, you have 3 minutes. If anybody gets the right answer, I will give you 100. And 100 means that I don't know how, if you were here, maybe we would go out and drink coffee together, or I would buy ice cream, or but you're so far away from here. So maybe Maka, if you solve this correctly, I will send it to your house. Okay. Is there any delivery in Azerbaijan, Baku?
Yes, fair.
Because here it is so fast. If you just order online, after maybe a few hours, not a few hours, in a few minutes, it's at your door. They actually service so quickly. Anyway, now the world is so small. Everything is online. Okay, guys, you have 2 minutes. We have one answer. Musa. Oh my gosh, it's a lot.
Mm,
What is it? It is 1,016,064.
yes.
It's too much, Musa. You are so generous. Maka, how about you? Any answer?
No, I didn't find the method.
Daphne, how about you?
Sure, I'm not even getting somewhere.
It's very easy question, Maka. Look, here we need to calculate, right? Usually, how do you multiply a number? We need to multiply, let's say, for example, here we have, let me just write here on the left-hand side. So here we have 1, 1, 1, 1, dot, dot, dot. Here we have 1, 1, 1, 1, 1. Let me just write a few numbers here. So I am going to multiply this by 2016. 2016. Okay. So how do you multiply this? First, I multiply 6 by all of these numbers. So I have here 6, 6, 6, dot, dot, dot. We have 6, 6, 6, 6, right? And after that, I multiply 1 by that number. So I have here 1, 1, 1, 1, dot, 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 1, 1, 1. And after that, multiply 0 by 1s. So here we have 0, 0, 0, 0, 0, dot, dot, 0, 0. And multiply by 2. So I have here 2, 2, 2, 2, 2, 2, dot, dot. Here we have 2, 2. And next, I just add them, right? So the 6 comes down here. So here I have 6. 6 plus 1, it is 7. 6 plus 1 plus 2, it is 9. 6 plus 1 plus 2, it is 9. And after that, as you see, all are the same until here, right? 6 plus 1 plus 2, also it is 9, 9, 9. And after that, 1 plus 0 plus 2, it is 3. 0 plus 2, it is 2. 2 plus just to itself. Now, if you look at this, right, until here, right, this one, right, and until here. How many 9s do we have here, Maka? Can you see here? How many 9s? It is just two numbers are missing, right, from 2016. So here we have 2014 9s, right? So that's it. Then the sum of the digit, let's say this S. Now the first one is 2 plus 2 plus 3. That is 2 plus 2 plus 3. And all others are 9. How many 9s do we have? As see here, if you look at this, right, until here, right, that is 2014. So that is 2014 ones. So here we have 9 times 2014. Plus, now I have here 7 and 6. Here we have 7 plus 6. That is equal to 2 plus 2, 4, 4 plus 3, 7, 7 plus 7, 14, 14 plus 6, that's equal to 20. Plus 9 times 2014. And you know how to multiply this. That's equal to 20 plus 9 times 4, 36. We have 3. 9 times 1, 9. With 3, it is 12. 9 times 2, that is 18. So now if you just add 20 to this, that is 181. It is 46. So that is the sum of the digits of this number. Okay, Maka?
Okay.
Okay, that is 6. It is 7. All right. It is 2, 2, and 3. Okay, that's 4, 7, 14, 20. And here we have 2016. 2 is missing. 1 here. Oh, 14. 9 times 4, 36. It is 46. Okay. So 18, 1, 4, 4, 5.
Daddy paper.
Hmm?
Just had daddy paper. Daddy paper.
Okay. All right, let's move to the next question. There's also another easy question. Maka, read the question.
In how many different ways can the letters of the word Sasmo be arranged so that two S are next to each other?
Very easy question. Guys, think, okay? And you have 2 minutes. Let's see. Okay, there's a small mistake, but we'll correct this later. Okay. Definitely, this question must be very easy for you. In how many different ways can the letters of the word Sasmo be arranged so that two S are
teacher,
next to
I
each other?
12.
12? Why?
Like SSAMO, ASSMO, AMSSO, AMOSS, and now MSSRO, like this.
Okay. No, actually, Musa, not like this. You should not count like this. How about if I ask you, for example, mathematics? M comes together. At the time, your method will be, it takes too much time. Just we are using, again, very simple counting principle. Here, since it's saying that two S's, right, they should be next to each other, I can just
it
consider
6?
this 2S as 1S, okay? So at the time I have these letters done. Here we have S means 2S together, and here we have A, and here we have M, and here we have O. So now that means that here, okay, because S is together, always they should be together. That means I can just consider this as a single letter. For the first place, how many choices we have here? I can write either as S or A or M or O, right? So I have 4 choices here. For the second one of them, right? One was already used. I have 3 choices here. For the third one, I have 2 choices here. For the last one, I have only 1 letter here. It's 1. So how many then? The number of actually words we can make where 2 S are next to each other is 4 times 3 times 2 times 1. That's equal to 24. Okay?
Teacher, I found 20.
20?
Yes.
How? Maka, it is 24. Okay, it is 24. It's very
Yes,
simple counting
I was
principle.
wrong.
We can just write, for example, SS, right? SS here. I can write here AMO in how many different ways? 6 ways. And how about actually the second one is SS here? Again, how many different ways? 6 ways, 6 ways, 6 ways. So it is 24 different ways. Because if you're given 3 letters, in how many different we can arrange it? 6 different ways. Anyway, guys, that's very simple method also to find the palindromic numbers. If you remember, we use this method. We call this simple counting principle. Anyway, let's move to the next question. Find the last digit of this number. Okay, so after the what we have here, Sasmo time is 3, and these are a little bit long question. Let's see, maybe when we have more time, we will discuss them. Okay, so here find the last digit of 1 to the power of 2016 and blah blah blah. Guys, we are running out of time. Let's do this and I will finish today's class. Okay, so we know that actually finding the last digit of the number, that means that it is the same as this question. What is the remainder if we divide this number by 10? Okay, so that means that if you're given any number, let me just write here, any number m, if you divide it by 10, the quotient will be something here, and this one is the remainder. That means that actually the last digit of n is equal to r, right? Because when you just divide this by n, we can just write it like this. That means, for example, 137. I can just write it as 10 times 13 plus 7. That means that if you divide 137 by 10, the remainder is 7, which means that the last digit of this number is 7. That's the first thing you have to know. Maybe later after Sasmo, if we continue preparation for CIMOC, at the time I will teach in detail about this stuff, because in the first stage, I don't want to go deep because you may get a little bit bored, okay? And we will see. And if you're really interested, then we will continue these classes later. And the second thing I'm going to tell you here is, okay, so now if you're given any two numbers, like, okay. So let me just group them like this. Here, since we are interested in the last digits, right? Actually, here, if I just write them first from 1 to the power of 2016, and plus 2, 2016, plus, and here we have 9 to the power of 2016. Because we know that the multiples of 10, right? The last digit is 0, so it doesn't have any contribution to the solution. I'm just ignoring them. Because 10 to the power of 2016, the last digit is 0, so we have nothing to do. We are just interested in the last digit. That's why I'm ignoring this. And how about starting from 11 to 19? Again, we can just take the last digits, 11 to 19. We have 1 to the power of 2016, and plus 2 to the power of 2016. And here we have 9 to the power of 2016. And if we just continue this until actually 2010. And from 2000 and 2010, again, here we have 1 to the power of 2016 and 2 to the power of 2016. And here we have 9 to the power of 2016. Let me draw a line. And after that, here we have 2011, 2012. I will just write them here. 1 to the power of 2016 and 2 to the power of 2016, and plus until 6. Here we have 6 to the power of 2016. Okay. All right, that's it. Now the next thing is, as you see here, if the last digit of this ones, right, whatever it is, if I find this, I should just multiply this by how many groups do we have here? We have 201 groups, right? And multiply by 1, 200. And after that, just we need to find the last digit of this number. Okay. And that's the idea. All right, we will continue in our next class, maybe in a more systematic way. I'll just write it down, okay, explain more details. 23, 24, 25, just let's leave this to the next class, okay? Guys, thank you very much. That's enough for today. Have a nice weekend. I will see you next Monday, okay?
Thank you too. Goodbye.
Yeah, bye
Goodbye,
bye.
teacher.
Nice
Bye
weekend.
bye.
Bye.
Thank you.